Okay, for this next one, we're going to handle this kind of similar to the way we handled the first one. We want to find the limit as x approaches infinity of this thing. So what we're going to do is we're going to look in the denominator, which is look in the bottom, and we're going to see what's the highest power of x. In the previous example, we had like x to the fifth, I think. In this example, x squared is the highest power of x. So we're going to multiply the top and the bottom by 1 over x squared. Our book uses the x to the negative 2 instead of 1 over x squared. It's the same thing. I just think if you write it this way, it's easier to see the cancellations kind of happen, I guess. And then remember, when we get stuff like 1 over x to the whatever, we can kind of figure out what's going on from there. So we got the limit as x approaches infinity. Let's see here. We have 7 halves of an x up top, which 7 halves is 3.5. We have positive 2 x's down below. 3.5 minus 2 x's is 1.5, which is x to the 3 halves. So the top will become 3x to the 3 halves. This will move over here to plus 7. When you have a negative exponent, that's down in the bottom. So we basically have, let's see here. We have x to the 2 x's plus an additional half down in the bottom. So that's 2.5 x's, which we could say is x to the 5 halves. And then, let's see here, down here these cancel completely. And here we have x to the 1 half up top. We have x squared down below. So one of the halves is going to go away. You get x to the 1.5, which x to the 1.5 is 3 halves. So we get times x to the 3 halves power. Okay, so now let's think as kind of what's going on here. As x approaches infinity, x to the 3 halves is just going to keep getting bigger and bigger and bigger. And stuff that's getting bigger and bigger times 3 is just going to continue to get bigger. So this part here is heading up to infinity. So this whole first term is going to infinity. As you get things that are larger, stuff that's getting larger and larger and larger, raised to the 5 halves power gets larger and larger and larger. And that means 1 over it gets smaller and smaller and approaches 0. So the top, we have the first term blowing up to infinity and the second term turning into 0. So we kind of have infinity plus nothing, which is infinity up top. The bottom, we get 1 minus, and as x's get bigger and bigger and bigger, the bottom here gets bigger, meaning the fraction tends to 0. So we get 1 minus 0, so we get basically infinity over 1, which says this thing just keeps growing up towards infinity. So that's the example 3 part A, and then we'll do part B in the next video.